G'day team, I'm back in the shed with the old man finishing off the plasma cutter, or the plasma table that we started building a couple of weeks ago. I've just been all over the place doing lots of different things. But I thought I'd jump in there first and say a big shout out to Sutton Tools. They're sponsoring this portion of the video. They've given me all the trade flame gear for all of our soldering, all of our heating, all of our wrapping. Beautiful soldering iron here, and our trade flame Ultima gas pack for doing all of our shrink wrap and all of our wires that are going to be hanging up there. And also our hole saws, bimetal cobalt hole saws from Sutton Tools, and their drills and their drill bits. If you don't know who Sutton Tools are, I don't know where you've been living, because they've been making drills for the last 100 years and they're still making drills in Kaipoi, Christchurch, New Zealand. If you need any drill bits, these are what you need to be using. So let's get back into this. I've got to make a couple of adjustments here. Fortunately on this is the y-axis. I made it too far over to one side, so I'm going to have to come and cut this weld out, shift it over slightly. Otherwise, yeah, I can't fit the motor in. But leave it with me and we'll start making some adjustments.
Like I said in the first video, the part that I got wrong was literally the only part that I needed to fabricate and weld, and I got it wrong. But the best part about making it yourself is that you can fix it yourself. It's all about having a crack at the end of the day. So once we got that fixed, we painted up the frame and put the casters on, and then it was all about reassembling it and putting together the motors and the wires and all the pulleys, which is a little bit daunting, but we'll get there.
So, I've painted it, put everything back together. I put casters on the bottom, which is actually giving me a bit more height, which I like. We've mounted the motor and the pulleys up the top, where the belt's going to come along and go in here around this, and that's going to give us this movement, the X-axis. And on this end, I've made this panel here, which is going to go on the back, which is going to give us our Y-axis, and I'll show you that once I've mounted it. But we're coming extremely close to the part where I've got to do all the wiring, and that's what I'm scared about, because I have next to no idea what I'm doing. But thankfully the download that you get from JD's Garage has like a schematic of how the wiring goes and all the components that you need to make it work. But like I said, I've got no idea about wiring or any of that stuff, so it's gonna be interesting and fun. Now we've got both motors mounted on the X and Y axis. Bearings here, these are going to act as sort of pulleys for the belt that are going to come across and drive it. When you buy these stepper motors, they just come with a straight shaft, and then you can buy these, and they just basically, depending on the tooth of the belt you use, these are 10 teeth, and they just have a little grub screw that locate on that flat spot, and it comes with your Allen key. I'll show you what that looks like on. But once that thing's here, there you go. Then you just push this on here. Then you can do the Allen key up.
No! God, please, no! No!
Just so you get it, the belt is going to go from either end of this, over this pulley, the stepper motor, through this here, and then on each end we clamped, and then that's how it's gonna run. So give me a little second, I'll mount them up and you'll see what I mean.
So once we mounted all the belt tensioners and put the belt around the motor in the right place, we had to basically work out how high or how low the belt was sitting in relation to the motor, and then adjust the tension so it's not too tight that it's trying to pull back the motor, and not too loose that it'll skip a tooth. We got it pretty good, and one little trick for you, those belt tensioners, they just didn't feel like they worked very well for us. And in the past, my old man's done belts where if they've got such a really tight mesh, you just use glue. So we ended up gluing our belts, and it worked great. It just had to hold them for a few moments. Once they mesh and you get like 3 or 4 teeth, or maybe I think we're about 10 teeth, super glued them, and they ain't going anywhere.
So I'm just about to drill a hole for our conduit. It's going to go up and hold the wires for our X and Y axis. And I've just opened the new Sutton Tools hole saw kit. And how good's this? It's got the quick release spring loaded bloody locator, and you just go down
and it locates itself. I prefer it to be a bit further down, but geez, it just saves so much time into the old school ones where you had to get it up, locate it, have a look where the holes were. It's this new way of doing things. I like it. These hole saws were insane. Not only did we have to go through that top layer, we had to go through 2 bolts and another layer, and we went through like butter.
So now that we've got the frame built and all the motors and all the belts on, it's the electrical part, and that's what I was worried about, because I'm f***ing terrible at anything to do with electricity. But you've got to push yourself, you've got to try new things. 10 meters of wire with 4 different wires in it. I don't know if you call that 4-core. The stepper motors that are on there have got 4 wires, so that was the point. So we didn't have to have individual wires going there, we can just have this solid one. 2-meter extension cord, we're going to cut off the end, so we'll just use this part. Plugging it into the wall for the power supply. Learned something else today. If you're using Arduino to connect to any of those little mini ports, you need to buy these. Like a little rainbow thing, but they've all got the tiny little pins, so that's going to be very helpful. Shrink wrap, you never have enough. This cord here, I'm not entirely sure what that style of connection is, but that's what the Arduino has on it with a USB in, so we can talk to the CNC Plasma table. The Arduino, cable glands for the box, and this beautiful electrical box that the boys at CSL have hooked us up with. These boys, legends. So like I said before, this is terrifying. I am definitely in the deep end here because I'm not used to doing anything like this. The only thing I've wired up is a car stereo, and that didn't go too well. But luckily, when you get the plans from the guys at JD's garage, you get schematics. And although that looks quite confusing, after reading it, it does look relatively simple. Just going to be trying to make it nice and tidy. So that's what I'm going to be doing now, and I don't think you want to watch me do every individual wire, so just see the fast thing. And for all the soldering that we're going to do on this job, we're going to use the trade flame dual power 50 to 100 watts. So this thing is a bit of a beast, and hopefully I'll be able to weld this nice and easy, or solder it nice and easy. I'll unbox it, show you what it's about. If you want to buy this stuff, I'll put a link in the video so you can see where to get it. So before I crack into the soldering, I thought it's important to mention, I've just plugged it in and got everything ready. It comes with 2 tips, so one's like a spade, which is nice and flat, which I'm going to be using on this because it can take, you can just sit all the wires on it and you can solder. I find it easier than these pins, but it's good, it gives you the option, and also it's pretty easy to use. Setting 1, 50 watts, setting 2, 100 watts. And also on the back, I've never seen this on a soldering iron, but it's got an LED light. How good's that? Make it super easy for you. Too good, trade flame, too good.
As soon as that touches, put the solder on. It's done. It's done already. Look, don't need more solder. Oh, look, fucking hell!
Nothing come off.
It's fucking welded. Soldered. Look, you got no ice. You've got worse ice than me. Fuck that burn, man. That's hot.
I've played in so many trades in my time, from plumbing, chippy work, building fences and decks, fabrication, building quarry equipment, rubbish trucks, car transporters, but when it comes to touching 240 volt, I'm shit scared. I don't know why, I think it's just because I hate shocks. But doing this process, it was super easy. Red wire went to the red wire, black wire went to the black wire. You just gotta really think about every single thing you do, and it was a simple process. We got all the drivers working, all the lights came on, and it started making noise without blowing up, so I was chuffed.
So now we've got our power supply connected, so that's on 240. All of our drivers have got power now. We've flashed the Arduino, however you say it, and we've got our controller in there, our 6-pin relay for the plasma. Everything's wired up and seems to be working. We've got lights all over the place, everything's making sound. We can jog this, so I've got it set, basically it's maximum opposite to 0, and I'm just going to see how this runs back to 0 once I press the back to 0 button. So everything seems to be running smoothly. I've just got to work out how to get a code onto here so I can do something like a figure 8 and just make sure, because you can only set a 0 in one corner, which means that you can't set a stop on all 4 corners. So I've just got to work out how that works. but that's what I'm doing now. So once I get a figure 8 loaded in there, I'll put it on and show you guys how that runs. But everything seems to be going really well. The belts seem to be going great. This bit of conduit we've got up holds the wires perfectly away from all the belts. So yeah, seems like a success so far. So we've managed to get our positioning right. So now we've got both axes zeroed out, and we've loaded in the JD's Garage file or G code. So it's sitting on there, and you can see the Y and X axis. And if I want to simulate, I can see this moving across and heading to where it's going to start its first cut, which is in the center of the G. So I'm happy with how that looks. So I've got all of this loaded up. So all I need to do now is press run job, and we should be away. Perfect. And that's so I can simply change the feed rate here into how fast it's going for when I'm cutting with the plasma cutter. So I've got to play with obviously the voltage or the amps that I'm using on the plasma cutter, but here I can change the feed. So once I get the voltage right or the amps right on the plasma cutter, then I can change my speed to make the cut smoother. Obviously that's the end goal. So it's pretty simple and straightforward, and looks like this job is a great success. Stoked.
And there you have it. It's all done. The next time you see this thing, it'll be hooked up to the new Xcel-Arc Cut 45 plasma cutter, and we're going to put this table to the test. Thank you so much for Sutton Tools for sponsoring. If you guys want to get your hands on any of those tools I used today or anything else from Sutton Tools, head to their website, suttontools.co.nz, and up the top bar you'll see the store locator. Use that and you'll find a store near you so you can grab any of their gear. And that's it. That's a wrap. Take it easy, team. Like I always say, get out of your head and into the shed. It's good for you. Good for the soul.